Hello, hi, and welcome to our YouTube channel, that is Raisal Maths Classes. I, Priyansh Rai, welcome all our viewers and subscribers to our channel. In today's video, we are going to study about the chapter Electricity of class 10th NCERT. So, let's start our video. Now, in this chapter, we have to learn about these specific points such as electricity, potential difference, electric current, and Ohm's law. So let's start with electricity. Now we are going to study about electric current. What is electric current? Electric current is the flow of electricity. So what will be its formula? So we represent electric current with the symbol I. The formula of electric current, or to find electric current if time and the electric current is given, so we can find it out. So what is formula? I equal to q upon t. Here I is electric current, q is the net charges or the charge that has been flowed, or time is uh, time taken by the charges to flow, and it is measured by ammeter, and its unit is ampere, which is represented as capital A. Hope you all understand this. Now we are going to understand some basic sequence of ampere. Ampere is the unit of electric current. So 1 ampere is equal to 1 CS inverse. So you are thinking that what is this C? C is stands for Coulomb, which is the unit of flow of charges. So 1 ampere is equal to 1 Coulomb per second, or we can say that 1 Coulomb 1 Coulomb second inverse. So I would like to solve this. So this is can be written as 1 ampere, or A we can write is equal to 1 is a constant value, so we write only like this, C S inverse. So by regarding this, we have to see that I is electric current, and A is the unit, or we can say the SI unit of electric current. So in place of I we can write A, and as I told you, net charges, Coulomb is the CI unit of net charges. So we write like this, A equal to, in place of Q we are going to write as C, and SI unit of time, as you all know, is second. So both are equal. This we can say that these two things are equal. Now we are going to see the next topic, that is potential difference. We represent it with V. So what will be its definition? So potential difference is the work done to move a unit charge from one place to another. It is the formula to find potential difference if work done or the amount of charges that had been flowed is given, so we can find it potential difference. Its SI unit is volt. It is also represented by V. So 1 V is equal to 1 joule per coulomb, or we can say that joule coulomb inverse. So we also find the unit by this formula. So as we all know, in the previous class we have studied that joule, that is represented by J, is the unit of work done, and in this chapter we have studied in the previous part of electric current that its unit is we can write Coulomb. Charges unit is Coulomb. So W upon Q is equal to J upon C. So it is also the same thing. And potential difference is measured by the device which is known as the voltmeter, because it is giving the unit in volt. Before starting the Ohm's law, we have to study about the most important factor, that is resistance. So in the definition form, we can say that the ratio of potential difference across a conductor to current flowing through it, or even we can say in the familiar word that resistance is like a speed breaker which reduces the flow of current that is flowing through an electric circuit. Its unit is ohms. We are going to study Ohm's law, so its unit is ohm and it is resistance. Now we are going to see two types of resistance, that is parallel resistance and series resistance. And this is the diagram of parallel resistance, in which the resistors are in parallel, and in this parallel resistance are in series, means in a continuous term. Now in parallel resistance, voltage remains constant but current varies, and in series resistance, or we can say series combination resistance, current remains same and voltage varies. It means voltage can either be increases or decreases in this type of resistance. And in parallel resistance, voltage remains constant but current varies, means current can either be increased or decreased continuously. Now, as I told you in the resistance part, that I am going to know you about some symbols that are required in the diagrammatical representation of electric current. So let us see some basic symbols. If you are making a wire like this, from this point to this point, sorry, you have, this line is a wire, or as you join a first wire to a second wire, so this diagram is used, joint wire. If the wire coincide or collapse with each other without making a joint, so you have to use this kind of symbol. If you are representing a cell, so this type of diagram you have to make for a cell. Or if you are representing a series of cell, or you are representing a battery, basically battery is a series of cells, so both for battery and a series of cell, we have to use a similar diagram like this. As I told you, voltmeter, so the diagrammatical representation in the electric circuit of voltmeter is a circular V. Now ammeter is circular A. As the previous topic of resistance, there are basically two type of resistance that we used in electric circuit. First is the normal that you have seen in some toys or something else. Basically it is like this, and another type which is used as the big buildings for making a proper flowing of current, or we can see in the DPs in our area, a variable resistance in which it gives one constant value or a variable. While solving it, it is a variable resistance. Now we have to use switch to turn on and turn off. So why we have written close and open here? In close switch, electric current flows, but not in open switch. So I have written open and close. This is the close, means electricity is flowing through this type of switches, and in this type of switches, when they are open, electricity are not able to flow. one more diagram, that is a bulb. We have to represent bulb like this. So our next topic after potential difference and resistance is electric current. So what is an electric current? Electric circuit is the continuous or the closed path through which electric current flows to operate a particular object or a thing. Now we are going to study about the Ohm's law, which was stated by George Simon Ohm. So what does its law states? This law states that the relationship between the potential difference, that is V, across a conductor. So what is a conductor here? Conductor means this is talking about the good conductor of electricity. So what is the good conductor? Good conductor of electricity that allows electricity to pass through them. So as we are very familiar with aluminum wire, silver and especially iron are the famous and the well-known good conductor of electricity. So where we are across a conductor, and I means electric current through it, means it is the relationship or between the potential difference. I have studied you about the potential difference in the previous. Potential difference across a conductor and electric current through it. This was the following law. Now we are going next, electric power. So what is electric power? It the rate by which electric energy is dispatched or consumed by a electric circuit. It is known as electric power. Its unit is volt, which is equal to joule per second or joule second inverse. Or 1 kilojoule is equal to 10 to the power 3 volt. So we represent electric power with a constant variable P. So what are its formula to find the electric power? So P is equal to VI, or it is equal to I square R, or it is equal to V square upon R. So next we are going to study some heating effect of electric current. So our last topic of this chapter is heating effect. So heating effect, there was a scientist whose name is Dewey, has stated a law in a form of variables that H is proportional to I square, that is electric current, H equal to R, that is resistance, H is proportional to T, that is time. So by this statement we got the formula of the amount of heat produced, that H is equal to I square RT. Now there is one more important it is not right to say topic, but an important point that can be asked in any competitive exams or in our board exams also. So that is kilowatt hour. So what it is, in our daily life the electricity bills came to our home monthly. In this you will find that how much unit of electricity we have consumed. So it is a unit. Why we call it unit? But it is not a unit, it is basically kilowatt hours, that how much energy we have consumed in a month. So it is equal to 3.6 into 10 to the power 6 joules. By completion of the heating effect, we have completed our NCERT chapter 12, that is electricity physics part. So I would like to thank all of our subscribers and viewers. Now I am heartily requesting all of you who are seeing this video to please like, share and comment, and please don't forget to subscribe our channel if you are new. So please subscribe our channel, press bell icon and put it at all. The videos we are making are literally, we are using our best effort and your heart-touching and lovely support gives a morale to make this type of video. For more videos, please subscribe our channel Riser Math Classes. We are also on Facebook and Instagram. You can also follow us there also. Thank you and have a nice day.